looking at more graphs of square root functions. So looking back to day one, we looked at the general form for a square root function as y equals a times the square root of x minus h plus k. Okay, this form shows us the general transformations that a square root function can have. So let's take, so remember, a represents the change in our stretch and compression of our square root, h represents the horizontal change, and k represents the vertical change. So taking a look at my graph here, okay, the first change that I notice is that instead of starting at 0, 0, we are starting at -2, -2. So what that means is that we have to move 2 to the left, and that we have to transform 2 down. So let's write that within our function. So I've got y equals a times the square root of x. Remember, you do the opposite of the sign. So since we are heading in the -2 direction, we need to write +2 as our transformation, -2. All right. So the next thing that I need to look at is, do I have a particular a value? So in order to calculate an a value, you actually need to take a point from within your function. So one point that I see in my function is the point 2, 0. You can pick any point for this. So I'm going to substitute 2, 0 into my form right now to calculate to see if I have a particular a value. So my y value is 0. So I've got 0 equals a times the square root of my x value, which is 2, plus 2, minus 2. So I'm going to go ahead and simplify this. So I've got 0 equals a, the square root is 2, plus 2 plus 2 is 4. The square root of 4 is 2. So I've got times 2. Oops, I'm going to try that again. So a times 2 minus 2. Okay, if I was trying to solve for a, I'd add 2 to the other side. So I've got 2 equals, I'm going to change my order here, 2a. So ultimately, you're going to solve that a equals 1. So since a equals 1, that essentially means that we have no stretch or compression. All right, so since we have no stretch or compression, we really don't need to worry about an a value. So the final the final equation for my function over here would be y equals the square root of x plus 2 minus 2, which is essentially what we have right here. Okay, the next thing it wants us to do is state our domain and range. All right, so our domain is our possible x values. So as you can tell from the graph, the lowest possible x value that I can have is at -2. And the greatest possible x value that I can have would be positive infinity. And same goes with y. The lowest value I can have for y is at -2. And the greatest is at infinity. So those would be my final answers right there. All right, let's take a look at one more. So with number 2, obviously, there's a lot of clear transformations for this one. So using the same form, let's start by identifying the shift to get to our starting point, which is actually up there. So to get to our starting point, there really is no horizontal movement. We're still on the y-axis. But as you can clearly see, we do head +3. So using our form, y equals a times the square root of x minus h plus k, I've got y equals a, we'll calculate that later, times the square root of x minus 0, since there's no horizontal transformation, plus 3, since we do transform up 3. Okay, I can simplify this to be y equals a times the square root of x plus 3. And now, just like the previous example, we are going to substitute a point in to solve for our a value. So I'm actually going to choose the point that they give us right here, 1, 0. I'm going to sub that into my function. So I've got 0 equals a times the square root of 1 plus 3. The square root of 1 is just 1. So I'm going to subtract 3 to the other side. Negative 3 equals 1a, which ultimately just means negative 3 equals a. Okay, so now I'm going to take my form right here, and I'm going to substitute negative 3 in for a. So my final function for this is going to be y equals negative 3 times the square root of x plus 3. All right, once again, let's find our domain and range. So looking at my graph, my possible x values, the lowest x value on my graph is going to be at 0, and my greatest is at infinity. And for x values, I can see that it's heading towards negative infinity, so that's going to be my lowest value. But the highest value I can have is right here at this point, positive 3. Okay, at this point, we have done quite a bit of work with domain and range, so if you still have questions, make sure you ask them during class. All right, page number 2 here. We are going to describe the transformations of these functions, create a table, and graph them. So remember, our parent function is just y equals the square root of x. Write that down. So we are describing the transformations that occur from this function. So let's just take the transformations one at a time. So the first transformation I'm going to describe is my a value, which is negative 3. So anytime you have a negative a value, it's important to state that you are going to reflect over the x-axis. Okay, that's what happens when your a value is negative. The next thing we need to state about our a value is, since it is greater than 1, we are going to vertically stretch by a factor of 3. Okay? So if it's negative, you reflect over the x-axis. If it's greater than 1, you're going to vertically stretch by a factor of your a value. If it is less than 1, you are going to vertically compress. Okay, the next thing I want to look at is my h value. So my h value tells me my horizontal transformation. And remember, it's the opposite of the sign that occurs in your function. So we are going to shift 7 spaces to the left, or in the negative direction. Okay, the final transformation that I want to talk about is my k value. So my k value tells me the vertical transformations. So I'm going to shift up 9 units. And I probably should have said 7 units here, but oh well. Okay, so those are my transformations of all 3 parts of my function. Okay, the next thing it wants us to do is create a table. So I've got x and y values. Remember, you really can pick any x values that you would like, but I'm going to cheat and choose just a couple of easy ones. So remember, for your x values, you are just going to substitute those x values into your function to find your y values. So substituting in -7, that's going to give me just 9. -6 will give me 6. 3 will give me 3. 2 will give me 0. And 9 will give me -3. So next, we're going to graph these points. So I've got -7, up 9, there, -6 and 6, -3 and 3, 2 and 0, and 9 and -3. So that's going to give me a graph that looks something like this. All right. So one of the final things it wants me to do is determine my domain and range. Okay, domain, my x values. The lowest value I can have is here, -7. And the greatest x value I can have is at infinity. I should have stated too, so the lowest x value you can have is whatever the x value of your transformation leads you to. So that's how I came up with -7. And my range, actually, since I have a negative, so since I'm reflecting over the x-axis, I actually have a maximum here. So my minimum is going to be -infinity, and my maximum is going to be up here at 9. Okay? The next thing it wants me to do is find my x and y axes. So for my x-axis, I can see that I have one right here. I actually found it out. So my x value, x-axis is going to be at 2, 0. And obviously I can't tell where my y-axis is. So in order to find my y-axis, I am going to plug in 0 for x and solve for y. So I've got y equals -3 times the square root of 7, 0 plus 7, plus 9. I actually can't simplify that, so that's my x-axis. Sorry, y-axis. It's going to be at 0 and -3 set square root of 7 plus 9. Okay, so that's what it wants us to do for every single graph. Okay, if you have questions, just mark the part of this process that you have questions on, and we'll make sure to take a look at it during class. All right, the final section here is we are looking at a graph, and we are supposed to so they give us a graph, we are supposed to write a function and then state the domain and range. So this is the same process that we actually did in the first section all the way back here on page 1. So I don't find it completely necessary to go through it again, but if you'd like the extra practice, feel free to go for it. All right, thank you guys for watching. Please bring any questions you have to class.